Hello, welcome. In this video, we're going to talk about solving 2x2 systems. And this is something that you should have done in Algebra 1, right? Solving with substitution and elimination with x's and y's. And in this unit, we're going to solve with x's and y's and z's, but I figured it would be good for us to start and review what we already know and practice that for a day. So let's get into it. When we have two variable equations, what we're really plotting is two lines in the plane. And in the last unit, we did a lot of graphing lines. So this can play out three different ways. We can have two lines that have different slopes. So maybe one's like this, and the other one has a steeper slope like this, and they intersect each other right here. This is what we would call a solution to the system of equations. A solution to a system is going to be an xy pair that satisfies both equations. And we would call that the unique solution situation. Okay. We can also have lines that never run into each other at all. And in geometry, we call those parallel lines. And we talked about parallel lines last unit. They have the same slope. So maybe they're like this. And I'll try to draw them parallel. That looks pretty parallel. And if they're parallel, they're never going to run into each other. So there's no xy point that sits on both lines. So we would say that has no solution. But there was a third thing that could happen. And that was where we were looking at kind of two equations of a line, and then it turned out that they were the same line. So if we had, like one, and then we got a second equation, and it turned out that it sat right on top of the first equation, well, then really there were a lot of points that sat on both, and that was where we said we had infinitely many solutions. But we didn't say that it was all real numbers because points, like this point right there, that doesn't sit on both lines, right? So there were infinitely many solutions, but it wasn't all xy coordinates, sat on both lines. That would not be the case. So we said infinitely many solutions when that happened. So let's do some examples and let's solve some of these algebraically. So the first technique that we're going to use is substitution. And I think that was probably the first technique you learned about in Algebra 1. And that's where when we've got one that we can have in terms of the other, we can just like substitute on that variable in the other equation and just kind of like proceed solving as if it was a one variable equation. So when we say that y is equal to negative 3x minus 5 and 5x plus 3y equals 1, we're going to substitute there on that 3 times y. So we'll have 5x plus 3y's, which now I know that y is negative 3x minus 5, and that's going to equal positive 1. So now I'm going to need to distribute 5x minus 9x minus 15 was equal to 1. So I'm going to need to combine like terms, 5x minus 9x, that's negative 4x. But then I could probably add 15 to both sides as well, and I could say that's negative 4x equals positive 16. And then I'm going to divide both sides by negative 4, and I would see that x is negative 4. Okay. Now, in order to get y, I've got a formula for y. I'm going to use that. Use the formula that you used for substitution. If you're going to use substitution, use that last to find the value of the variable that you substituted on. Well, y is going to equal negative 3 times x, which I now know is negative 4, minus 5. And then y would equal positive 12 minus 5 is 7. So my solution coordinate is negative 4 and positive 7. Okay. Now if I wanted to check my answer, which is something that I would recommend you doing sometimes, especially if you're unsure of your answer, plug negative 4 and 7 into both equations and make sure that both equations are true. If I plug negative 4 and 7 into the second equation, I would have 5 times negative 4, that's negative 20, plus 3 times 7 would be 21, so I've got negative 20 plus 21, that does equal 1. Okay, so I've got myself a solution. Okay. The second example, I think this is one that you should try on your own. Okay, so if you're watching at home, you should pause the video, in just a second and work this on your own, and then resume watching because the answer is just about to pop up here in a second. All right, there you go. So I did substitution on x. I said negative of 5 minus y, which is going to reverse the signs of both 5 and the negative y, plus 2 more y equaled 13. I cleaned up some terms. I discovered that y was equal to 6, and then I plugged back in to find x, and I found that x was negative 1, and then I've got myself a solution. This is substitution. I'm going to show you now, and then I'll just give you a kind of a good selection of practice problems as we wrap up the video. All right, now with elimination, there's a couple of things I need to remind you about, and that what we're doing here is that we're like adding copies of an equation to another equation. And, you know, I don't really want to get too deep into the theory of elimination in this video. I just want to show you how to do it. But what I'll say is that if you're curious about this at all, come talk to me, because this is the type of thing that we study in depth in my linear algebra classes. Matrix algebra is the theory of solving systems of linear equations. And so I've got a whole lot of things to say about this, but I'm just going to like refrain from doing that and instead just show you how to eliminate. But really the key is that we can multiply equations by a number, and we can add equations to one another and subtract equations from another. But my advice in my class is that I stick to adding equations to one another and multiplying by negative numbers to make that addition as good as possible. Okay, so what you're going to grow to recognize is when you see this positive 1x and negative 1x, you're really well set up for substitution. So what I'm going to do here is I'm going to add these two equations together. Now, if two things are equal, then you could add two other things that were also equal and preserve that equality. That's the principle at play here. Okay, so when I add 1x plus negative 1x, or x minus x, that's 0. Okay, so 0 is not going to really contribute anything, but if I add y plus 2y, I'll have 3y, equaling 14 minus 5 is 9. Well, 0 plus 3y, that's just 3y, right? Because if you add 0, you haven't done anything. So I'll have 3y equals 9. I'll divide both sides by 3, and I'll get y equals 3. Okay? And then I can go back to one of my original equations, like, I don't know, x plus y equals negative 5. And substitute with 3. So x plus 3 equals negative 5. I would subtract 3 from both sides, and I would get x equals negative 8. So my solution point would be x equals negative 8 and y equals 3. Okay. So once again, why don't you try the one on the right? If you're watching at home, you should pause because the solution's just about to pop up here in a second. All right, there you go. So we did elimination very similar to the last one. It was very well set up for it. We didn't have to multiply any of the equations by anything. We just added them together and the y's went away. We ended up with 6y equals 6, x equaled 1. Okay, then it turned out that y was not an integer. And it's good that we ran into that early, right? Because in general, they can't always assume that the solutions to these problems are going to be integers. But x is going to be 1, y is going to be 8/3. And if you were doubting yourself because you didn't get a whole number there, we could go off to the side and we could check. And I'm going to actually show you me doing that, like writing it out this time. So 2x is going to be 2 plus 3y. Well, 3 times y is going to equal 8 because y is 8 divided by 3. So that's equal to 10. And then 4x is 4 minus 3y. Well, 3y again is going to equal 8. And 4 minus 8 is equal to negative 4, so, you know, I'm happy. Both of these equations are satisfied by the point where x is 3 and y, or where x is 1 and y is 8 divided by 3. That was elimination. But not every system that we run into that we're going to need to solve with elimination is going to be perfectly set up for elimination where we just add the two equations together and one of them disappears, right? We're going to run into situations like these two where we have to manipulate the system in order to get it to eliminate. Okay, so for me, I'm looking at these and I'm looking for ones that kind of have like opposite sign and one is a multiple of another. Okay, 3 is not really a multiple of 2. I mean, I could multiply the first equation by 1.5 to get 3y and 3y, but I think it would be easier to multiply the first equation by 3, right, to get 3x on top and 3x on bottom. Now, me personally, I would prefer to have negative 3x on top and negative 3 on bottom so we can just add together and not worry about subtraction because I know that I make a lot of arithmetic errors and subtraction is a place where arithmetic errors happen frequently. So what I'm going to do is I'm going to kind of label these equation 1 and equation 2. Okay. And then I'm going to say, all right, I'm going to take negative 3 of equation 1, and I'm going to copy that in here. So I'm going to take x and multiply it by negative 3, 2y, multiply it by negative 3, and negative 5 multiplied by negative 3. And then I'm going to copy in equation 2 because that's my idea, is to eliminate x. Okay, so I'm adding these two equations together. And this thing where I'm writing equation, or negative 3 of equation 1 plus equation 2, this isn't super essential this time, but next time, once we go work in 3x3 systems, there will be a lot more to keep track of. And so I'm just doing this so that when I go to start doing this with 3x3s, it will seem familiar. All right, so here we are. We're going to add these equations together to eliminate x. I'll have negative 6y plus 3y is going to be negative 3 times y. 15 plus 9 is 24. If I divide both sides by negative 3, I'll get y is negative 8. Okay? I'm going to choose one of the two original equations to plug back into to find x. So I think x plus 2y equals negative 5 would be a good one. Okay, then I'm going to plug in negative 8. Okay, so that's x minus 16 equals negative 5. I'm going to add 16 to both sides. 16 minus 5 would be 11. Okay, so my solution point is x equals 11 and y is negative 8. Okay, now this next one, this one's, you could eliminate x if you wanted to, but I think this is better set up to eliminate y. I'm going to give you a hint. I would recommend doubling doubling the second, obviously you're trying to double y to get to negative 2y, but you want to double the whole second equation so you don't change the solution, and then add together. So try this one on your own, and then check your work against mine that will pop up here in like 3 to 5 seconds. All right, there you go. So I doubled equation 2 and added that to equation 1, and then I discovered that 1x equals negative 5. And then from there, I was like, okay, well, I'll go back to the easier of the two equations at the beginning. I decided 2x minus y equals 0 looked easier. And I plugged in on the x that I discovered, found that y is negative 10, kind of mentally checked my answer, and now I'm confident that the answer is where x is negative 5 and y is negative 10. All right, now here's two more where none of them are multiples of the other, okay? And I'm going to need to just pick one and scale both equations to set up for elimination, okay? So this is like maybe the worst case scenario for 2x2 elimination. Okay, besides the numbers coming back disgusting, but that's hopefully not going to happen in this class, right? They might not be whole numbers, but they shouldn't be, like really, really, really bad numbers. But, what is a really, really bad number? At this point, it's kind of hard for you, the student, to know that. So we're going to go over here, and we're going to work on these. This is going to be equation 1. That's going to be equation 2. That's a good first place to start. Okay, so I need to, both of these, it doesn't matter which one I pick. I can eliminate x. I can eliminate y. It's not going to make any difference which one. It's going to work exactly the same way. I say, let's just eliminate x. It's on the left. So we're going to look for a common multiple of 2 and 3. And so that's going to be 6, right? If you don't see anything in common. Or if you aren't seeing it, just multiply the first equation by the second number and the second equation by the first number, if you see what I'm saying. It's 2 and the negative 3. So what we're going to do, I'm going to multiply equation 1 by 3 and equation 2 by 2. I'm going to add them together. So 3 of equation 1 is going to be 6x minus 9y equals negative 48. Okay, and then 2 of equation 2 is negative 6x plus 4y equaling 38. Okay, now I'm set up for elimination, right, with that 6x and that negative 6x. So I add them together, I get no x's, negative 5y's equaling 38 minus 48, that's negative 10. Okay, divide by negative 5, and I'm going to get y is equal to 2. Then I'm going to go back to the easier looking of the two original equations. I'd say maybe 2x plus 3y. So 2x plus 3y equaled negative 16. 3y is going to equal 6, so 2x plus 6 equals negative 16. Okay, I'm going to subtract 6, and then I'd have 2x equals negative 22. And then x, I'm going to divide by 2, and I get x is negative 11. So my solution point is negative 11 and 2. And we could go and we could check our answer. So negative 22 minus 6, that's not negative 16. I've made an error. Okay, let's figure out where is this error. I see it. It's a copy error right here. 2x plus 3y. It's 2x minus 3y. So maybe I could go in and I could fix that. Okay, 2x plus 3 minus 3y equals negative 16. 2x minus 6 equals negative 16. 2x equals 10, and then x would equal negative 5. That might give me a better chance of having a right answer. Okay, that's the value of checking your work, right? Is that you can catch an error before you go too far and you embarrass yourself on video, right? So this is going to be -5. So I go and I check my answer. 2 times -5, that's -10. Minus 6 more, it's -16. -3 times -5 is 15, plus 2 times 2, okay, is 15 plus 4, that's 19. Okay, it works, good, great. Okay, we saved ourselves an error by checking our solution. That's the message here. All right, on this one, you could, if you wanted to eliminate x, you'd probably multiply the first equation by 7 and the bottom equation by 2, or -2. If you wanted to eliminate it on y, which that's probably what I'm going to do, again, you're going to pause the video and work it on your own and check your answer, I'm going to probably multiply the top equation by 2 and the bottom equation by 5. But again, pause it, work it on your own, check your answer against mine. That's going to pop up in 3 to 5 seconds. Okay, there you have it. Okay, so like I said, I multiplied equation 1 by 2 to get to 10y, equation 2 by 5 to get to -10y, and then I eliminated on y to leave myself with just x's. Okay, got 39, x equals 39, that was promising, right? X equals 1, and then I plugged back in on one of my original equations and got my value of y, reported my solution. Okay, so I think that's a really good selection of elimination problems to range from really, very basic elimination to, having to do the most with. And now past that, you really just need to practice your substitution and elimination, right? You can watch me do these all day long, and it's not going to do nearly as much as you just sitting down and grinding out a few of them. Okay, I'm going to say, all right, we'll do the same thing a couple more times. I'm going to tell you to pause the video because you practice and then check your work against mine. I'm going to just put my work in right here and give you the answer in a couple seconds. All right, there you go. I had a tough time fitting all of my work for all 4 of these in the space that I had previously allotted, so I put them side by side. But you can, pause and investigate these solutions farther if you like. I would point out on the 4th one that I worked in orange. I imagine that you probably decided to eliminate x. And I just wanted to put it out there that, you can eliminate on x, you can eliminate on y, you can eliminate however you want, right? You can use substitution on ones that look like elimination, as long as you solve for one of the variables. It does not matter. And the biggest thing that I want to emphasize to you is, substitution versus elimination. I would like for you to be fluent in both, right? Confident, fluent in both. But whenever you look at one of these systems of equations, whatever your first instinct is, I want to use substitution on that, I want to use elimination on that, that's what you should go with, because your first instinct is probably the technique that's going to be most likely to lead you to the right answer. And I want you to work with confidence. Okay, so that's big, is going to be choosing the method we're most confident with. Okay, past this, you just need to practice on the homework. Okay, I've got homework problems, I've got even more homework problems, extra practice. So just keep doing substitution and elimination until you feel confident. And if you do a bunch of them and you're still not feeling confident, you should come talk to me about that. But otherwise, that's going to be all I've got for you for this video. Thanks for watching.